Hello, am I audible? Cool. So let's start actually. For how many of here is this the first time you're attending this conference? Oh, nice. So we have a lot of new people also. Sounds good. Um, okay, a little introduction about me. So I'm Praveen Thirumurugan, and so I work in an insurtech startup called as Plum in Bangalore, India. So we create an interface for HRs and employees to access health benefits. So that's one of the coolest things that we are building in India. Also, I'm a cloud practitioner, so I like to architect a lot of solutions in cloud, including in GCP and AWS. So that's one of my work items as well at Plum. And also, I lead two communities back in India. So one is GDG Coimbatore and one is GDG Cloud Coimbatore. So we create conferences and also host sessions like this every time in my own country. And I also have an app called as App Geek. So in part time, apart from my office work, I work on this app. So you can explore that at appgeek.io. And yeah, I like to travel a lot. And currently, I'm on a vacation, a month long vacation actually. So I came to the US like last month and already explored a lot of states and planning to do more in the next 10 days as well. So yeah, so this is how I came. So far liking the United States a lot. So explored a lot of places already. So going to explore Utah in the next 2 days and also hope there are a lot of things to cover. Okay, so let's get back to business. Heard about monoliths? How many of you know monoliths? Probably many would have been working on monoliths even now. So let me give you a brief overview on how monoliths work. Um, Say there is a product that you have built or a big company that has a lot of things. So in typical monolith architecture, so everything would be bundled in one single code base, and a lot of services and a lot of teams would be working on the same repo. Please do not confuse it with the monorepo, but it's kind of little different. And almost all the applications as well would be talking with the same, the same services. Say here it is written in ASP.NET and it has a common place where it is hosted. So this is how a typical monolith structure would be. And either you could self-host it on yourself, your own machine, or you'd be using compute instances or any other compute ways to host those monolith services. And certain advantages would be all code would be on a single code base, can be, and it could be easy and fast to deploy as well because it is a common repo. End-to-end testing is also easily integratable between services in the same repo. Data consistency could also be bought, and it could be easy to understand if all the developers are working on the same tech stack. But it quite doesn't scale well, or it is not the best practice to use on modern applications. This can be subjective or augmentative, but yeah. So these are certain disadvantages that we could see in a typical monolith architecture. It can be prone to unknown errors. Every time a new feature has been built where a team is not involved, still new deployments would be happening. Testing would be redundant actually, and it can be difficult to migrate if you want to move into new tech stack because all the teams would be working on the same tech stack, and decoupling certain services would be difficult. Okay. So let's take an example actually. Let's imagine that this conference has a swag ordering system. So these are the typical things that could happen, right? So whenever you try to place an order or place an order with your credentials, you need to update the inventory, notify the merchant, perform fraud checks, and a lot of steps, right? These can be sequential. So what do you think the disadvantages could be here? Anyone? So every time you place an order, it cannot be like you can wait till 30 seconds or 1 minute to process the order, right? So there are certain steps which you can eliminate in this process, or you could offload and take it async. If you see here, all that we need is to update the inventory in the DB and confirm the order. So all the other things can be taken async, right? So not everything needs to be done instantly, can be done in an async way. The user need not wait till the request is completed. We can just notify that, okay, we have got the order, and we would be processing it, and we would be, I mean, successfully delivering your order in the next, in an async way. So this is where microservices can come into play. So what you can do here is we are going to split the code base into multiple smaller chunks. So this way, it has a lot of advantages as well. Let me give you an example. So this was the monolith deployment that we had earlier, right? So now we can split it into these kind of systems. So the orders microservices can run on a separate platform. It can have a separate runtime as well. Similarly for other microservices. So if you see here, one runs in App Engine, one runs in Cloud Functions, and even if you see the runtime, one is in Java, one is in Node.js. So you have these kind of advantages. Okay, but before going to the next thing, so there are also other advantages as well. Uh, if you're a team that is scaling up, you can have separate teams that are working on separate microservices, and each team would have the liberty to work on their own terms. You can hire a set of team which are specialized in Java, and another team which is specialized in JavaScript, uh, and also different other parameters, right? In case there are certain vulnerabilities in Node.js, the team can isolatedly fix them alone, and the other microservices would not be affected. Okay. So coming back to this, so what are the ways through which microservices can talk with each other? So one good way would be HTTP based methods. So here, even if you see, even if you want to contact with another microservices, you'd be awaiting for the response from the another microservice. So this could still be a problem for you, right? So it can be a, uh, time bottleneck for your applications. But this is one of the methods. Second method is you could have database triggers, right? So in case you're using a NoSQL database like, Firebase or Mongo, what you could do is once you write something to the collections, there can be triggers which can lead to multiple subsequent actions or subsequent executions. So this is one of the methods. And the next thing is event-based triggers based on PubSub. So this is how, this is where I'm going to give a demo as well very shortly. But if you see here, once you place an order, right? So what we are going to do is we are going to create a PubSub event on a topic. So this would be like I'm informing PubSub that I have something to share, I have a message to share, and I would be posting that message to the topic. And there can be consumers which could consume that message, or even the PubSub architecture can push the message to certain HTTP endpoints. Uh, it can be async, right? And it could also notify a lot of services on a single topic message. I'd be showing you how it's done as well. Um, so yeah, so this is how we started with, right? So whenever you wanted to order something on the Swag portal, so what we would need to do is, do a lot of sequential steps. But with PubSub, we would be replacing that and we would be making it like this. So earlier, if you see, there were from steps number 2 to 7, it was sequential. And now there are only 3 steps. So the first step would be we update the inventory. So once the inventory is updated, the second await call would be to publish the message to PubSub. So here we are, emitting an event, and there are multiple services that could consume that event. So the merchant service could consume that event, process the order in its own term. The notification service can also do it async in its own term, right? So if you want to send emails or SMS or WhatsApp messages to a certain group of people, that also can be done async. So that need not wait for other services to complete. And finally, if you have additional things like reward service, right? In case of Amazon, if you want to get certain cashbacks, or if you want to get coupons based on your order, that can also be done parallelly. And now the API speeds would be like Flash, right? Okay. So if you see here, this is the interface for PubSub. Maybe I think I can zoom it a lot. So here, if you see, this is the GCP platform, and here you could actually go to PubSub, and here you could create topics. So a unit of PubSub would be topics and subscriptions. So here we have something called as UtahJS accept request. So that's a topic I have created to show a demo today. But if you see here, to create a topic, all that you need is a topic name. And if you want to enforce a strict schema for the message that is coming into the topics, you could also use a schema. And talking about subscriptions next. Okay, so once a topic is created, you land into the screen. So here, what you need to do is you need to create subscriptions inside PubSub. Subscriptions can be of two types. One is push type and one is pull type. Push type is something like if there is any kind of message that is posted into that topic, PubSub architecture would automatically push that message to your services. So it's pretty simple actually. So you just give a subscription ID. And if you see here, delivery types, they have, four types of deliveries. One is pull, push, write to BigQuery, and write to cloud storage. Here, push is something which we are going to explain it here. And the endpoint URL would be the API endpoint that PubSub needs to call whenever a message is posted here. And if you want to enable authentication, you could enable JWT based authentication as well. So here what you would need to do is you would need to select a service account which you would like to authenticate. For example, you cannot accept requests from any public endpoint, right? So you need to authenticate whether this request is actually originating from PubSub and whether it's originating from your project. So anybody can try to call your APIs and it should be authenticated, right? So what you could do is you could create a service account. A service account is like a credential, and PubSub would automatically sign that service account and create a JWT token. And whenever it's going to call this endpoint URL, whenever a message is posted, it would automatically give you the JWT headers as well so that your application could authenticate it. And certain other metadata is also available that you can configure, like how long that message should be available for, to push or consume, and when would it expire, and whether uh, the acknowledgement should be coming in within 10 seconds or 10 minutes. So in case your API is going to take a lot of time, we could actually set the acknowledgement deadline here. And and there is also something called as dead letter. So this is very important. As you try to explore more into PubSub, you would be getting into this. um, I mean it can be any architecture, right? It can be Kafka, or in case of AWS it could be queuing system, right? SQS. There are parallel products available on the market, but almost all the products would have similar naming conventions or terminologies, and uh, the products that they offer would be almost similar. So dead letter is something like in case your API is not responding 200 or 2xx status, in case it is responding with 400 or 500 for time being, what this architecture could do is it could retry for a certain finite number of times, like 5 times or 10 times. And if it still fails, this could push the same message into separate dead letter topic. Think it of like a separate pub sub topic where you post all the messages which has failed, so that you could retry on your own terms. Maybe you could have the expiry terms like 30 days. You could revisit your dead letter and find which of the messages has failed. Those kind of stuff can also be made. So for example, if you see here on the topic that we have created for demonstration in this conference, so the push endpoint would be something like send email. So whenever a message has been posted into this topic, we would try to call this endpoint so that email could be sent. Uh, Remember that uh, you're not limited to one or two push endpoints inside a topic. You could create as many subscriptions as you want. So if you see here on the subscriptions tab, right? So we have only one push subscription. But if you want to notify other microservices or if you want to call other endpoints, you could also do here. Like if you want to save something on your Google Cloud Storage in case of a message comes up, along with sending the email, you could also do that. So these are certain kind of advantages when you are going into event-based architecture and event-based triggers. Um, so if you want to experience it firsthand, I could show you something like this. Um, if you want, you could go to this website right now. So this would be utahjs.praveent.com. So here, if you want to, you could get the agenda of this conference if you're trying to use that. Let me show you. So this would be the website actually. So all that you would be entering is your name and email address if you want. Uh, and what this would do is the code visible? Cool. So this is a simple endpoint. Think separate endpoints as separate microservices. I could not create multiple microservices here, but I'm just assuming that separate APIs or separate microservices for just the reason to use this demo. See here. So this is where my API runs actually. So what it does is it does nothing. So all it does is it creates a PubSub message and it posts into the topic. So here what I'm doing is this is the topic name, and message is something that can be descriptive or it can be a JSON also. It would be encoded in base 64 when you receive it in your endpoints. And attributes are something like whatever you want, you could post it into the attributes. See here, I'm publishing name, email, the conference name, and the date when this request was originated. So if you see here, when I try to publish this, so the message would be delivered here, and it would deliver to all the subscriptions here. So once that subscription is the accept push request, a request push. And here it is going to call this endpoint with all the attributes and messages that we have configured. So this is the endpoint that it is going to call. And if you see here, I'm going to get the attributes and I'm getting the name and email from the attributes. And I'm using my own email SDK or any of the SDKs that you want. For example, here I've used resend. So I'm trying to send email using that SDK. And so this is one of the simple atomic APIs that we have built. So similarly, you could build multiple APIs from multiple microservices, call them parallelly, and it would be executed async. So in case if you see here, So if you see here, the time taken is actually 0.5 seconds, right? So this is a very simple atomic example that I've given. So there can be very, very, very complex scenarios. Uh, Say the recent SDK is going to take like a second or two to send the email, right? It can become 2.5 seconds if it was not async. So here what we have done is we are just publishing the message. So it just took 0.5 seconds, and there can be multiple sequential actions that can be done. And if you see here, not this, yeah, here it is. So if you see here, we have already got the email. So this is how event-based triggers are made. So yeah, just giving you back on how this SDK is actually used. It's actually very simple. So what you need to do is you need to create a service account that you could use to authenticate your request with PubSub. So PubSub has SDKs on almost all the runtimes available, right? So here even you could get it on JavaScript up and running. So you could just use your project ID and your credentials to authenticate your request. And sending is very simple, as we told earlier. All that you need is a topic name, set of attributes that you would like to send, and also a message that you would like to send. Once you have done that, it's pretty much easier, right? So this is how it was actually done right now. So all that you did was you updated. I mean, the first step actually I skipped because I did not want to collect any personal information. I created an event on PubSub. And here again, if you see earlier, I had another service as well, another push subscription to store certain things on DB. That, I mean, actually, I've eliminated it right now. Uh, but we did send the notification, right? So through a separate HTTP endpoint. Uh, Say in case I want to save your details on my DB as well. So that can be done on a separate endpoint, and it could be executed on parallel as well. So even if you have 100 tasks that you would need to do on an event update, you can do it with PubSub. Uh, so talking about disadvantages, still, I mean, it's augmentative, but still, it does not execute sequentially, and also you cannot uh, confirm that it would be executed only once. So the notification service could also be called multiple times. This could be based on the load that your PubSub topic is getting. So this could lead to duplications, right? So it's better to have an idempotency key in the attributes whenever you're trying to push something, so that you don't create duplicate events. And if you want to be absolutely very sure that you don't want to get duplicate events, then you would need to go with alternate architectures. Uh, so one such way is queues or cloud tasks. Cloud tasks in GCP is something like you could schedule certain tasks to be run on a separate, I mean, on a particular time frame, or if you want to execute it, I mean, immediately also you can do that. But it gives you rate limiting options like how many tasks should my application accept in a second or a minute, how many parallel executions should be made from cloud task architecture. So these kind of additional configuration options you would also get it with cloud tasks. I think similar services would be also available on Azure or AWS. So yeah, so the I mean, you would be able to navigate your disadvantages as well, but uh, if you're trying to build an application from ground up, or if you're trying to make your applications more faster, or if you want to improve the latency times of your mobile apps, you could think of certain architectures like this. So this should obviously help you in a lot of places as well. So yeah, I think that's about it. That's the end of presentation. If you still want to get the agenda on the email, you could still do that. It's utahjs.praveent.com in case you need. And yeah, thanks. If you want to follow me on Twitter or X, you can do that. Thanks.